2.
How do I know if it's going?
Yeah, it is.
Okay.
Thank you. And hopefully you've already been able to figure that one out. It should have been nice and simple. The vertex is the point in the middle, so that would be S. The sides are the rays coming from S, so that would be ST and SR. The rays, ST and SR. 3 ways to name the angle. Angle RST, angle TSR, and then angle S. Is this a acute, obtuse, right, or straight angle? Right, because of this square, right? Alright, and then to move on, we've already talked about congruent before. We had congruent segments, now we're going to have congruent angles. That still just means they're going to have the same measure. So the measure of angle A equals the measure of angle B. Remember, that's just the lowercase m that stands for measure. So you can say angle A is congruent to angle B. Remember, this is the symbol for congruent. Now, whenever we had congruent segments, there was a little dash mark on those segments to let you know they was congruent, right? Now you have kind of the same thing with the angles, but it's just going to be a little congruent arc in the middle of the angle. And so anytime you would see 2 angles with these marks, that would mean that they are equal or congruent. And so that's something to remember. Now if you flip over, we had segment bisectors last week. This week we have angle bisectors. So it's going to do the same thing as a segment bisector done. It's just now it's an angle, but it's a ray that divides an angle into 2 congruent, which means equal, angles. And so if I look in the diagram on the right, the ray BD is an angle bisector because I have this angle ABC and this ray BD is splitting that in half. So that makes the angle ABD congruent to the angle DBC. Now there's some important stuff to look at here. How many angles are up here? There's actually 3, because remember, if this ray BD wasn't there, I would have this angle ABC, right? So I have the big angle, and then I have the 2 smaller angles inside of that big angle. So that would make 3, right? So let's say I know BD is splitting that in half. So let's just say this side is 40, this angle is 40. The angle ABD is 40 degrees. Anytime you want to know what the angle measure is, it has to be in between your 2 sides of the angle. So if this angle is 40, this angle would be 40. But then what if it asked you, and this is getting to some stuff we're going to do tomorrow, what if it asked you for the measure of the angle ABC? ABC is the whole thing. So it'd be 40 plus 40, which would be 80. And we'll come back to more of that in a little bit. We're going to do more of that later on down the road. The next little bit is more terminology. Perpendicular is a word that you probably should have heard, but you probably don't remember. But perpendicular lines are two lines that intersect. That means they cross, right? Or they touch at least. And when they do that, they do it at a right angle. So they would make a right angle. So if I'm looking at this picture, line L and line M cross. Because of that box, I know when they cross, they make a 90-degree angle, which means they are perpendicular lines. The symbol for that is an upside down T. Basically two lines that would be perpendicular anyways. This is the symbol for perpendicular. How I would say two lines are perpendicular is you would write line L is perpendicular, so I've got the symbol is perpendicular to line M. And then of course, if you're naming the lines with two letters, you would just use those two letters instead of L and M. Do what? The next term basically just puts the two things we just did together. If I have a perpendicular bisector, that means it's a line segment or a ray that is perpendicular to a segment and it's at its midpoint. So that means if I have a segment and I have a line split in half, it's already a mid-segment. But if it's split in half and it's 90 degrees, then it becomes a perpendicular bisector. So in the diagram on the right, the line LM is the perpendicular bisector to the line PQ, or the segment PQ. So, example 3 and 4 is kind of just takes what we did on the first page to a little bit more level, to a new level, because there's a lot more going on in this picture, right? The important thing to remember is I can make an angle with any three of these letters, but what's the vertex going to be for every single angle of it? B. B is the vertex of everything, right? So B is going to be in the middle. And this is what I was talking about whenever we're naming angles. Now that there's more than one angle that has the vertex B, I can't just say angle B. Because if I say angle B, I have no idea what angle I'm talking about, right? So I'm just going to write this here. If I put angle B, that would not work. That would be wrong. Now, if you have something, we'll just jump to example 4 before we do it real quick. If I have something like this, and it has the numbers inside of there, I can say angle 1, angle 2, angle 3, angle 4, angle 5. But I can also still use the letters, like angle 5 and angle WTY would be talking about the same angle. You either have to use the numbers or the letters. You can use both. So before you do 4 on your own, we're going to do 3. Stop for a second. You'll do 4, and we'll go over it, and then we'll have some work to do. But if I'm writing another angle for angle CBF, that is this angle here, I can't say angle B, so what's the only other way I can do? FBC. I just have to go in the opposite order, right? B, it says name the sides of the angle EBD. That's really easy. I don't even have to look at the picture, but we will. Angle EBD is this angle. Remember, these sides start at the vertex and go out, so that would be the side, the ray BE. And then the other one would be the ray BD. And what I was saying about you don't even have to look at the picture, this tells me the sides right here in the name, right? So I know B is the vertex, E has to be on the other side, D has to be on the one that's not E. So there's my two sides, BE and BD. When it says to classify the triangle ABC, that means, say, if it's right, straight, obtuse, or acute. So I go over here. Make sure you always just trace from A, B to C, because that helps you. But if I start at A and I trace down, I just drew a straight line, right? So that would be a straight angle. Then it says give an example of an obtuse angle. There's multiple answers here that work, but there's also answers that could be wrong. The easiest one I'm going to do is angle CBE, because there's nothing else in that. But that would be bigger than 9 degrees, right? So I'm going to say angle CBE. But you could also use any three letters with B in the middle that if you traced it, would be bigger than 9 degrees. So I could say angle ABC. I could say angle FBA, or angle DBE, or angle EBD, right? As long as if I trace those three letters, it would be bigger than that 9 degrees. Name two congruent angles. Which two angles have those little arcs in them? So these two right here, right? And so this is where it's kind of important. The angle it's talking about, this is in between your two sides. So my two sides are AB and EB. Well, B has to be the middle letter, so I can say angle ABE. Now if you said angle EBA, it would still work. And so down here I'm going to say angle FBC. This one, name a perpendicular bisector. So if I remember, a perpendicular bisector is a line or a ray. So it's not an angle. That would be BD, right? So I'm looking for the perpendicular, which means 90 degree angle. Here's my 90 degree angle. This ray is the one that's cutting through AC to make that 90 degree angle, right? And I know it's the bisector because then it splits AC into those two equal parts. So, right now, take about the next 5 minutes, do example 4 on your own, and then